Welcome to IT.Solution, your total network, system, firewall, and security partner.
Welcome back, Focus Learners. I am seriously thrilled you're tuning in today, because we're going to unpack the completely invisible infrastructure that makes the entire internet actually work. In today's explainer, we're tackling protocols and models. Now, I know that sounds super technical right out of the gate, but I promise you by the end of this, you are going to see the digital world in a completely new way.
Okay, let's dive into this. Think about it for a second. How does a single click on your mouse turn into a fully loaded web page on your screen almost instantly? The devices, the physical wires, the servers, they're all made by completely different companies. Honestly, without strict, universally agreed upon rules, the internet would be absolute chaos. We'd literally just have a massive mess of ones and zeros crashing into each other.
So here is our roadmap for the explainer today. We'll start with the rules of communication, then move into network models and blueprints. From there, we'll look at the TCP/IP protocol suite, trace the encapsulation journey, and finally, figure out how we go about reassembling all that data. These structured models we're covering, they are the literal blueprints of networking.
All right, kicking things off with Section 1, the rules of communication.
Just like you and I need a common language and basic etiquette to have a conversation, computers rely on a very specific set of logical rules to exchange information, and we call that set of rules a protocol. It's actually a lot like the real-world rules of the Postal Service. If you want a letter delivered, you can't just scribble a name on a blank piece of paper, right? You have to follow their strict rules. Return address in the top left, destination address dead center, stamp in the top right. Network protocols enforce that exact same kind of rigid formatting.
And these protocols, they have incredibly important jobs. They handle addressing to make sure we know who the sender and receiver are. They ensure reliability, giving us guaranteed delivery. They manage flow control so data doesn't just totally overwhelm a device. They sequence the data, they detect errors to catch any corrupted bits, and they interface right with your applications. These protocols are essentially the guardians that guarantee a message gets from point A to point B without getting corrupted or lost.
Moving right along to Section 2, network models and blueprints. So with all these different protocols doing all these highly specific jobs, how does hardware from dozens of competing vendors actually know how to play nicely together? Well, this quote from the source material hits the nail on the head. It says, you can think of a networking model as you think of a set of architectural plans for building a house. Think about it. When you build a house, your electricians, your plumbers, your framers, they all need a master blueprint so their work doesn't physically clash. It's the exact same in the digital world. Software developers and hardware manufacturers absolutely need a unified networking model. But who's actually drawing up these blueprints? Well, it takes a village of standards organizations. You've got groups like the IETF maintaining internet protocols, while the IEEE defines standards for things we use every day, like Ethernet and Wi-Fi. Then you have organizations like IANA and ICANN managing IP addresses and domain names. Because they create these open, shared standards, a Cisco router can seamlessly forward an email to an Apple laptop without skipping a single beat.
Now, what's really interesting here is how we make sense of all this complexity. To make networking digestible, we break functions into stack layers. If you compare the historically significant 7-layer OSI reference model directly to the more modern TCP/IP model, you can see exactly how these blueprints map out. That older, foundational 7-layer OSI model actually maps seamlessly right onto the streamlined TCP/IP framework we use today.
Actually, if you look back at networking history, there was a bit of a format war going on here. The OSI model was developed first, but it got bogged down by a really slow, formal standardization process. On the flip side, TCP/IP, which was originally created by volunteers, won the marketplace hands down. It won because it was open, it was standardized, and it was ready to ship. Today, TCP/IP dominates the internet, even though we still use OSI layer numbers as our universal networking vocabulary.
Which brings us to Section 3, the TCP/IP protocol suite.
And this brilliantly illustrates the winning blueprint that powers your devices right now. The TCP/IP suite groups protocols into 4 distinct layers. Right at the top, the application layer has familiar acronyms you've probably seen, like HTTP for web browsing and DNS. Moving down, the transport layer relies heavily on TCP for reliable delivery. Right below that, the internet layer uses IP for routing your data. And down at the very bottom, the network access layer uses Ethernet or Wi-Fi to physically transmit the data. It's just a perfectly orchestrated stack.
All right, Section 4,
the encapsulation journey. This is the climax of our explainer.
This is where we get to watch a piece of data actually travel top-down through this entire protocol stack. But before we trace that journey, we need to quickly lock in the concept of encapsulation. Remember our postal analogy from earlier? Encapsulation is exactly like taking your written letter, which is your data, and placing it securely inside a stamped addressed envelope, which acts as the header. Every single time data moves down a layer, it gets placed in a brand new envelope.
So, imagine you hit send on a web page request. Bam! The application layer hands the HTTP data down. The transport layer quickly slaps a TCP header on it so it's reliable. It passes down to the internet layer, which slaps an IP header on it for routing. And finally, the network access layer wraps it in an Ethernet header and a trailer. In literal milliseconds, your raw data is wrapped in multiple layers of absolutely crucial instructions. And here is a fun fact. As the data gets encapsulated at each of these layers, it actually changes names. We call these protocol data units, or PDUs. So at the application layer, it's just data. Add the TCP header, it becomes a segment. Add the IP header, now it's a packet. Add the Ethernet header and trailer, it becomes a frame. And finally, for the actual transmission, it's converted down into raw bits.
So the crucial point is noticing how the original email or web data starts at the very top, and as it passes down the stack, a new block, a new header, is attached to the front of it at every single step. It's honestly like a set of digital Russian nesting dolls. The data is securely tucked inside a segment, which is inside a packet, which is inside a frame.
Once that final, fully encapsulated Ethernet frame leaves the web server, it gets pushed out onto the physical wire. But at this point, it is no longer recognizable as a web page or an email. It is simply a continuous, rapid-fire stream of electrical or optical pulses, just ones and zeros, traveling at near the speed of light.
Finally, Section 5, reassembling the data. What happens when it reaches the destination?
Let's move to the final step and see how this builds. Those ones and zeros have traveled across the globe and finally reached the network card on your laptop. What happens next? Well, your device performs de-encapsulation. If encapsulation is putting the letter into the envelope, de-encapsulation is just the reverse. It's simply opening the envelope, reading the instructions, and pulling the letter out.
The client device takes in those raw bits and processes them from the bottom up. First, it reads and strips away the Ethernet header from the frame. Then it passes the packet up and strips away the IP header. It passes the segment up, reads and strips away the TCP header, until finally only the raw requested user data is left. That user data is then handed directly to your web browser, and boom, the web page magically appears.
I want you to think about the sheer magnitude of this for a second. Billions of packets are being encapsulated, transmitted, and de-encapsulated on your device at this exact second just for you to watch this explainer. Millions of tiny, logical rules firing flawlessly in the background. It is an absolute modern marvel. So, as our network demands continue to explode with things like AI and the Internet of Things, how far will this invisible infrastructure scale in the future? I'm going to leave you to ponder that. Keep learning, keep questioning, and I'll catch you on the next explainer.
Thank you for watching. See you in the next episode.